Hello and welcome to my channel. Tonight's video is going to be about the moon and how it's turning like a clock and it shouldn't be. Now I'm going to show you photographic proof and a YouTube video that shows how it's doing it in the northern hemisphere. And I'm also going to show you how or why it shouldn't be by showing you a couple other videos. One video was made by the BBC. And the other video that explains it will be a children's education video, because we're going to try and keep this pretty simple. Because if children can understand this concept, then any adult should be too, logically. Alright, pictures. Now I took this last year. I borrowed a camera from work for a night. I actually happened to be working that night, so I had the camera on the truck and took the pictures. I mean, I knew that the moon was turning like a clock or turning cartwheels, depending on how you want to think about it. As you can see, at 8 p.m. and midnight. These are from the same location. It's just, as you can see, it's late spring or early summer, so therefore it's still light out. But later on at midnight, it's the sun is fully set and it's dark. So that's why we have different times. You know, light to dark. Now you can take pictures of the moon with your smartphone during the day and get plenty of detail to do this. And a lot of times you can capture this during the day of the moon turning like a clock. But at this time you were having, it would rise like this, and throughout the night it had turned clockwise because we're in the northern hemisphere. On the southern hemisphere, it will do the opposite. It will turn counterclockwise. Or if you're from the southern hemisphere, they say anti-clockwise. At a rate of 15 degrees an hour, you'll see this. So we have 4 hours here. 4 times 15 is 60 degrees. We've got roughly about that in these pictures. So 15 degrees an hour, you got to understand something is the Earth rotates on its axis at the exact same speed, 15 degrees an hour. And why we are now seeing the moon do this is because the Earth is tilted on its side. Now our perception of the moon is changing at 15 degrees an hour as the Earth normally turns on its axis. It's not a seasonal tilt thing. This is happening every night, and the moon is changing at 15 degrees an hour. The direction depends on what side of the hemisphere you're on, and it's doing it equatorially as well. I'm just not sure on the direction in which way it would spin on the equator. It may not at all. I'm not sure, because I don't know anybody. But I know, as I've confirmed with some of my friends, northern hemisphere and southern hemisphere, outside of equatorial areas like Australia, mainly, in the southern hemisphere. So, as I was saying, it's not the moon doing the cartwheels. It's our perception of the moon is changing at 15 degrees an hour as we rotate on our axis. That provides us, and that axis spin provides us night and day. It's not field rotation. That's a camera setting, because cameras don't have necks. Alright, so you've seen the two photos. I've got hundreds of photos. These are time stamped. Now I'm going to show you a video from this channel. Now I'm going to just hit play. And there's no audio on the video. And you can see when he captured it with timestamps. This is the phenomenon I'm talking about. Turning like a clock. This is obviously a northern hemisphere video because it's turning clockwise. Alright, so in the first part, you can clearly see he's got a timestamps, and you can see the time progress. Okay, now, since you've seen video of that, let's go here. And I'm just gonna play this video because it's all relevant.
Hello, kids. Space Pro Planetarium welcomes you to this show on the lunar cycle. Have you ever seen the moon on a clear night sky? If you've observed the moon carefully, you would have seen that it doesn't look the same on all nights. On some nights, the moon is big and round, and on others, it is a thin slice of light in the sky.
I'm going to pause here because I want you to see this crescent moon, the tips are vertical. Remember that. The tips are vertical.
Have you ever wondered why the moon looks different every night? You will be surprised to know that the way our moon looks to us is not as much about the moon as it is about the sun and the earth. Strange, isn't it? Let's understand how. The moon always has a spherical shape like a basketball, but it doesn't always look that way to us. We always see exactly half of the moon. Some of the time, that half is lit by the sun and we see it. At other times, it isn't lit by the sun at all, and we can't see it. Most of the time, the part of the moon that we see is partially lit by the sun and partially shadowed. The moon looks different to us depending on where it is in orbit. Remember, the moon revolves around the Earth once every 29 days. In other words, once a month. As the moon moves around our Earth, we see a different part of it lit by the sun. When the moon is on one side of the Earth and the sun is on the other, we see one half of the moon that is bright with sunlight. This moon is called the full moon because we see a full round circle. Each of the positions of the moon in orbit has a name. Let's look at what they are. When less than half of the moon is lit by the sun, it is called a crescent. When more than half of the moon is lit by the sun, it is called a gibbous. Waxing gibbous indicates the part of the moon that is lit and growing, whereas waning gibbous is the part of the moon that is lit and shrinking. Based on what we just learned, let's look at the different phases of the moon. There are 8 phases in all. We'll now explore each phase of the moon. The lunar cycle begins with the new moon phase, when the moon is not visible from the Earth. This is because the half of the moon that faces away from the Earth is lit, and we only see the dark half. During the waxing crescent phase, we begin to see a very small part of the moon
The tips are vertical.
lit by the sun, but most of it is still shadowed. In the first quarter phase, only one half
Still vertical.
of the moon is visible from the Earth. This is because the right half of the moon appears lit, and the left side of the moon is still shadowed. In the waxing gibbous phase, more than half of the moon appears lit by the sun.
Still
When you see a
vertical.
waxing gibbous moon, you know that a full moon is just a few days away. During the full moon phase, the moon is on one side of the Earth,
Notice the craters have not changed at all.
and the sun is on the other. The sun illuminates the half of the moon that faces the Earth directly, and the moon looks like a full round circle. In the waning gibbous phase, the other half of the moon is lit by the sun, and we see it looking like a little less than a whole circle. The waning gibbous moon looks like it is shrinking, doesn't it? But it's not. In the third quarter phase, the left half of the moon appears lit, and the right side of the moon appears dark. During the waning crescent phase, the moon looks like a crescent. This moon signals the beginning of a new cycle, and means that you will see the new moon in a few days. Here is a quick quiz on the lunar cycle.
Alright, so as you saw in this children's education video, you didn't see this. They didn't explain at all the Terminator line turning like a clock. And you'll notice the craters are coming right along with it. It's not... If it was the moon turning like a clock, the Terminator line would stay vertical, but the craters would come out of the shadow, or down here they would go into the shadow. Well, you don't see that. Now, as far as the Terminator line, you could take a ball and a flashlight and shine it and simulate a Terminator line with a flashlight and a ball, or a baseball, or whatever, golf ball, and you'll realize that you can't make a shadow roll. So, it's not and why I say that is that means I'm explaining that the light that's hitting the moon is not going around either. So it's not the sun, because we all know the sun is not orbiting over our north and south poles. It stays to the east and west along the ecliptic plane. So these two explanations rules out that it's not the moon and it's not the sun. So there's only one thing left, that it's the Earth. The Earth is tilted on its side, so now our perception rolls of the moon as the Earth turns on its axis. Now, I just want to be clear that the author of this video, and I'm not trying to start anything with the guy, just would like to say his beliefs, and that's his. He believes that the moon is self-lit, and that is why the moon is doing this. Well, the whole seeing the craters, let me back it back up, seeing the craters turn along with it is also proof that it's not self-lit. If it was self-lit, the Terminator line would move and the craters would come in and out. You know, the light would transfer around, therefore lighting up new craters, and then the shadow would cover up. Well, we're clearly not seeing that. So it's not self-lit, it's not the sun, it's not the moon, it's us. And the moon is not fake either. It's still just the moon. Okay, so another great source that we have found is the BBC. It did a video about the moon. And, excuse me, I gotta sneeze. And in his explanation, he goes with hemisphere specific moon and how it looks the northern hemisphere compared to the southern hemisphere. So as we see the moon turn in this video, and you'll look at the BBC video, you'll learn that the moon is very specific and should not change no matter where you stand on the planet. The moon should rise and set in the exact same orientation from our perspective, no matter where you stand on the planet.
And made me want to understand the way it all changed each night, including the one thing that everyone knows.
Tonight we have a beautiful big bright moon framed by the pinnacles. And because it's so close to Earth, it's by far the easiest thing for us to see.
Did you see the moon halo?
And we don't need any special equipment to see it either. Your own eyes will do just fine.
No prizes for recognising this as the moon, but you might spot that something seems not quite right about it. Compare this picture, taken from the UK, with my Australian view. You can instantly see that the moon looks a different shape. The shadow is on the other side.
Northern hemisphere, southern hemisphere.
But that's not all. Look more closely at the patterns on the surface.
The big dark area on the left of the moon is the Sea of Tranquility. It's the place where Apollo 11 landed.
The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
So let's compare the view that we've got here tonight with the one that you've got in the UK.
The Sea of Tranquility has jumped to the right-hand side. That's because the moon you see is the other way up from ours. So how is that?
Notice he said left and right sides, not top, not bottom lit.
Everyone on Earth is seeing the same moon at the same time. We see it a different way up because we are a different way up. So we're going to use my motorcycle helmet here to represent the Earth. And we're going to use this little camera to represent you sitting on top of the Earth.
Northern
If you imagine
Hemisphere?
that my face is the moon, the view from this camera shows how you'd see it from the UK. The right way up.
And if we travel from the UK to Australia, we're going to go around the curve of the Earth until maybe I look a little different. So going around to the other side of the Earth means that we see things in a different way because one of us is upside down. And I'm not sure if it's you or me.
Our opposite views of the moon turn its monthly phases on their head too.
We see the same phase of the moon.
See, he's showing the moon phases throughout the month, but you'll notice the terminator line is not changing its orientation at all. Doesn't say, oh, it's rising this way and setting this way in the same place. He's being very hemisphere specific.
Moon from anywhere on Earth at the same time. But the way we see that moon depends which way up we are.
Viewed from Australia, this crescent moon a good week before full moon looks like the letter C. While for you in the UK, the same moon looks more like a capital D.
Alright, so to recap, all you have to do to see this yourself is go outside, look at the moon, say just as it rises. Go take a nap, come back 3-4 hours later, and look at the moon again. And you will see this. Alright, now, for the people that like scriptures, you can look at Isaiah 24:23, and it talks about a confounded moon, or confused moon. Well, I would say we have a confounded moon. Alright, well, thank you for sticking through this video. I appreciate it. I encourage you to share, because this is an important issue and it doesn't require any equipment to look at. All you got to do is go outside and look twice. And once you realize this, you'll start looking at the moon all the time. You'll start looking at when am I going to see it again? Because I want to get pictures, because I want to show more people. Well, that's what you need to do, is show more people to understand that it's the Earth is tilted on its side. And I've explained every which way why. It has shown you that it's not the moon, it's not the sun, it's not self-lit, it's not fake. It's the Earth on its side. And from our perception, it's turning like a clock. The direction depends on the hemisphere you're in. Okay? Thank you for watching.